Okay, so for the rest of the lesson, we're just going to wrap up some of the concepts and properties that we looked at for exponential functions. So the first slide we're going to look at is exponential functions, comparing y equals b to the exponent x and y equals 1 over b to the exponent x. Or in other words, comparing exponential functions where the base is greater than 1 versus exponential functions where the base is between 0 and 1. And so it says, describe the behavior of the graphs of y equals b to the exponent x and y equals 1 over b to the exponent x. And what you'll notice is that their behavior is opposite. So for y equals b to the exponent x, the function is increasing. And you can see that in the graph as well. So the function is actually increasing. And so what that means is, as the value of x gets larger, so does the value of y. And so as x approaches positive infinity, the value of y approaches positive infinity. And as x gets smaller towards negative infinity, the value of y decreases towards 0. Okay? So this is an increasing graph. Normally when we're reading a graph, we go from left to right. But if you're actually approaching it from the left or approaching it from the right, you want to think about how the y values are changing. Okay, for y equals 1 over b to the exponent x, so you'll notice that the graph is going down and to the right, so this is a decreasing graph. Okay, and so because it's decreasing, what happens is as the value of x gets larger, the value of y is actually getting smaller. As the value of x gets smaller, the value of y is getting larger. And so if you look at their end behaviors here, you notice that they're actually opposite to each other. They're not the same. As x gets larger here, y gets larger. But as x gets larger here, y gets smaller and starts to approach 0. Okay? As x approaches negative infinity in the first one, y approaches 0. Whereas x approaches negative infinity in the second one, y approaches positive infinity. So their end behaviors are opposite. Okay, so exponential functions of the form y equals b to exponent x and y equals 1 over b to exponent x. What is common to all of these graphs that we've been looking at? So one of the things that have been common to all of them is that they have a y-intercept of 0 and 1. And so what that means is, when I plug in x equal to 0, I always get a result of 1. And that makes sense because think about what happens if you plug in 0 in the first one. Y equals b to the exponent 0. Well, I know that any base to an exponent of 0 gives me a result of 1. So that means x is 0, y is 1. There's your y-intercept. Same idea for the next one. If I plug in 0 for my exponent of x, then any base to an exponent of 0 gives me 1. And so that's why the y-intercept is still 0 and 1. Okay, the y-intercept occurs when x is equal to 0. Any base raised to an exponent of 0 gives a result of 1. So we just talked about that. So therefore, regardless of what the value of b is, or what the value of the base is, y equals b to the exponent x will always be 1 when x equals 0. The other thing that's common between all the graphs is that they all have a horizontal asymptote at y equals 0. Okay, so the horizontal asymptote for all of them is at y equals to 0. So no matter whether the function is increasing or whether the function is decreasing, you'll notice that they have the same y-intercept, and they both have a horizontal asymptote at y equal to 0. Okay, is there an x-intercept? No, there is no x-intercept because the value of y can never be 0. So what that means is, what you're trying to determine is, if there is an x-intercept, that means y would equal 0. And so if I try to look at y equals b to the exponent x, and I set y equal to 0, is there a value of x that will make the statement true? And no, there isn't. There is no value of x that will ever make that statement true. Okay, and that's the reason why you have no x-intercepts. Any number raised to an exponent will always have a value, but will never result in 0. Okay, so you'll never get, this statement will never be true. No value of x will ever make the statement true. Okay? Y equals b to exponent x and y equals 1 over b to exponent x again. Is there a quick method to sketch an exponential function? Yes, there is. Okay? If you're just sketching, then all you really need to remember is you have an x-intercept at 0 and 1, and you have an asymptote at y equal to 0. Okay? If you're given a base that's greater than 1, then all you need to do is draw a curve that's increasing. So let's say you have y equals 8 to the exponent x. So I know that the x-intercept is at 0 and 1. Sorry, the y-intercept is at 0 and 1. I know there's a horizontal asymptote at y equal to 0. And I know that because the base is greater than 1, the more I multiply 8 by itself, the larger it gets. So I'm going to have an increasing graph that will look like this. One end will approach the asymptote, the other end will approach positive infinity. Okay? So as x gets bigger, y gets bigger. As x gets smaller, y approaches 0. If the base is between 0 and 1, so let's say you have y equals 1 over 5 to the exponent x, what this means is I still have a horizontal asymptote at y equal to 0. I still have a y-intercept at 0 and 1, except because the base is less than 1, I know that the graph is going to get smaller and smaller and smaller, and so this is going to be a decreasing graph. And the reason for that is because as I multiply 1 over 5 by itself more and more and more, the denominator is getting larger, so the function is getting smaller. So when is an exponential function increasing? It's increasing when the base is greater than 1. And when is it decreasing? When the base is between 0 and 1.